All right, welcome. My name is Kevin Williams. I'm with ClearEdge 3D, and I'm going to be hosting today's Workflow 4.0 series, where we're going to be talking about as-built hospital BIM, case studies, and best practice scan-to-model workflows. Here's just a short overview of what I'd like to accomplish today. I'm going to start off by talking about just a little bit of background on the hospital MEP workplace. And then I'm going to introduce our speakers. Melinda Hoffman, who is a virtual design manager at LP Simonelli, and she's going to be talking today about an Erie County Medical Center renovation project that they've been working on. Next up is Alan Sly, who is an electrical design engineer with P2S Engineering, and he's going to be talking about the Huntington Memorial Hospital BIM project that they've been working on, creating MEP systems, modeling those. Then at the end, we're going to have some time, hopefully, to be able to ask these guys a little bit more about their projects. So we'll get some audience questions and pick their brains just a little bit on some of the unique challenges that they faced in these projects. So just a couple of house rules here. We've got about 500 or 600 people signed up for this. So obviously we need to keep everyone muted during this session except for the presenters. However, please feel free, if anything that they say piques your interest, please feel free to ask questions via the question window in the GoToMeeting control panel during the session. Now we won't interrupt their presentations, but we will have 3 distinct sessions where we'll be asking them questions. Once immediately after Melinda's presentation, again immediately after Alan's, and then again at the end. Now this webinar is being recorded and you'll each receive a link to this webinar afterwards. And then finally, if you haven't done so already, please subscribe to Workflow 4.0. It's a great e-newsletter for just keeping up with everything going on in the reality capture marketplace. So just a little bit of background on the hospital marketplace. It's a massive market right now. There's an estimated 124,000 facilities just in the top 7 industrialized countries. That's the US, EU, UK, China, South Korea, Japan, and Brazil, and more obviously in the rest of the world. Now the thing about this is these facilities are aging. They've been there a while. The average age of the MEP plant that's kind of the heart of these facilities is about 15.5 years old in the United States. So that's a ripe old age for replacing and updating some of these facilities. Now obviously that's an expensive process, but the cost of refurbishing these facilities and replacing and updating and modernizing them is substantially cheaper than new construction. And so between the age of the plants, economics of healthcare in general, and then changes to the way we're providing care. So people are moving towards shorter hospital stays, they're moving towards universal care units instead of specialized care units. All these different changes are driving this hospital refurbishment trend. And bottom line is, if you're in the laser scanning industry, and you know what you're doing, and if you understand these unique needs in this industry, the medical center industry, it's a huge opportunity. So with that, let me introduce our presenters today. First up, we'll have Melinda Hoffman. Melinda, can you please introduce yourself? Just give us a brief overview of your background, please.
Sure, thanks. My name is Melinda Hoffman. I've been in the AEC industry for a little over 12 years. I started in the AE side, working for an architectural and engineering firm, became a Revit technical specialist, so I'm Revit certified professional, and then I transferred over into the construction world about 3.5 years ago. So that's a little bit about me and the background of where I'm coming from.
Perfect. Thank you, Melinda. Alan, can you give us a brief overview of your background, please?
Thanks, Kevin. My name is Alan Sly. I have my bachelor's in electrical engineering from Cal State Long Beach. I'm pretty new to the industry. I've been working about a year and a half here at P2S. But over my time, I've learned a good grasp on power, lighting, fire alarm, telecommunication systems, and we've acquired our scanner about a year ago. So we've worked on multiple scan-related projects for various applications.
Okay, perfect. And then my name is Kevin Williams. Again, I'm with ClearEdge 3D. We're known for our Edgewise software application that does automated feature extraction from point clouds. And so that's my background, my interest in the scanning reality capture marketplace. So with that, I'm going to hand over the controls to Melinda and let you take it away, Melinda.
Okay, thanks, Kevin. So just perfect. Okay, so a little bit about the company I work for now. We're a construction management general contracting company. We also do some design build and P3 program management. We purchased our scanner about a year and a half ago. Since I've been at LPC and a little before, we've done about 22 jobs in coordination for building information modeling and 3D modeling. Of those 22 jobs, 11 of them have had some sort of laser scanning component, whether it was in the proposal stage gathering information, whether it was coordination, whether it was as-built. We've used the scanner in many different scenarios, even in a scenario with the Coast Guard to create a pattern for a shoring system, which was pretty interesting. And we have offices in Buffalo and New York City. So let's see. There we go. The project I'll be talking about today is Erie County Medical Center. This is one of the largest hospitals here in Buffalo, New York. It's a 550-bed hospital that was opened in 1912. It's a teaching hospital. This particular project was the 6th floor renovation for universal care and orthopedics. Along with that, we've done numerous other projects at ECMC. We've built a new long-term care facility, which was 720 beds, behavioral health, which was quite a bit of outpatient clinics, and we also used the scanning in that facility as well. And we also did a dialysis center. So we've been at ECMC Hospital for a little while, and we finally gotten the owner to understand and really get a feel for what the scanning technology can do for them and provide for them. So this particular project, we were able to scan after demolition. We were provided a Revit model from the architect, and this model was what we were to use for the background of our coordination. The problem was the demo hadn't been done, so none of the MEPs above the ceiling had been recorded. And because this was a floor in the middle of the hospital, we needed to know what was there that needed to be remaining. There were a lot of types of steam pipes for heat. There were sanitary lines from the floor above running to the floor below. There were also a lot of electrical systems. So for this, we really wanted to do a demolition scan to start with. The floor was about 28,000 square feet total. Our deliverable was a 3D as-built for the coordination. So basically, not necessarily walls, but modeling all the MEPs that needed to remain that we could coordinate around. So the time frame was interesting. This project was executed in 4 different phases, which created a lot of challenge for us. Basically, I was challenged with having to call the project manager up, hey, can we get out there? Hey, can we get out there? As many days as I could, because if we didn't keep on top of them, we would miss our window. So that was one of the challenges. And when we did go out there, as you can see in the images over here, this hospital actually has 4 different wings. The one wing, which is right here, we didn't actually do any renovation for, but we did on the other 3. So that's why we had to phase it, because they were working in different zones at different times. So some of the challenges for this particular project were just having a lot of people in the area. We had to wait until the demo was complete before we could scan. However, when we got in there to scan, there were still some things that were existing that were supposed to be demoed but weren't yet. So having to have somebody mark up after the scan was done what was to remain and what was to be demolished, so that we didn't model anything that wasn't going to get. Oh, sorry, somebody was talking, sorry. So that we didn't model anything that wasn't going to be in there. But because of the time restrictions, we could only get in there when we were given that window. So we weren't able to wait till everything was done because of the expedited schedule. So basically, we went out 3 different times to scan to get all the demolition captured. There's a little bit of a lag. There we go. For this specific project, we created piping for the existing radiant heating and completed the coordination with the existing piping where it was not thought in the design phase. One of the biggest things we found when we started scanning this building was that the architectural design model was actually off by a foot in the width direction. So when you lined it up, it was 6 inches on each side. This actually caused a problem with some of the chases that were outlining the current radiant heating. The chases had to be made bigger, and a few of the spaces had to be reconfigured because of ADA zones. So one of the other things was, because we had to do different scans at different times, piecing together the scans done at the different times was also a challenge that we ran into. We tried our best with being able to register by planes, and that seemed to get the job done. And then the other thing that we did for this project was, as an example of what the scanner technology could do, we did some pre-board scans. This was quite a challenge with the expedited schedule. Because we had 2 shifts running on this project, it was tough to get in there when there was nobody working. So we ran into problems where there were people in the scans, but because this wasn't actually a required deliverable, it was just something to show them what we could do. It wasn't as huge of a deal, but highly recommended if you're doing pre-board scans to do it when there's nobody around. It definitely compromised some of our scan data. Now, we purchased a Faro X330, and we used Scene, Edgewise, and Revit in order to be able to get the collection. Basically, they would give us a call and say the demolition was done, you can come out and scan, and I would take the scanner out, and another person would come with me to assist in setting up the targets. We scanned Zone 1 first, which was part of the Universal Care Unit. We would set up the targets based around subcontractors' equipment or wherever we could find places to put it. So some of the areas were compromised because of large bins holding different equipment or tools, which was a little bit of a challenge as well. Also, even though they were supposed to keep it fairly clean, there were piles of debris here and there. So luckily, we weren't doing a flatness levelness calculations, but in that case, we would have had a lot of problems with the calculations on that too. We scanned each zone post-demo and then documented where all of the information was, steel beams, as well as MEPs. And then the last part was, once the model was complete, verifying what was staying. So in the image to the right, you can see the electrical panel boxes. Those were actually there to remain. They were getting built into a new wall. So we had to make sure we modeled that and allowed for that in the space for coordination. Each zone had about 12 to 14 scans, which meant we used all of our targets and then moved them around, since we only have about, I think we have 11 or 12 sphere targets, and then the rest were paper targets. So moving them around as needed, trying to figure out which ones needed to remain to stick them all together. Basically, the total scan number was about 50 for the demolition. Setting up the targets, roughly about 20 minutes, and then we only did black and white scans since we didn't need color. This really wasn't going to the owner. This was for internal use only, so we typically try to stick with black and white just so that we can collect it in the fastest time possible. One of the things we always tried to do was make sure at least 3 spheres are in the scan. This allowed us to quickly and accurately register them. I found even more than that is okay, so I typically do overkill. But the 2 scans on the right, you can see I've circled the spheres that are actually the same names that overlap. As far as the modeling workflow goes, we would use Scene to register the point clouds. Basically, check and see the QA/QC if they lined up properly, how they came in, and what the data looked like. Everything was stored on our C drive. We actually, at one point in time, were trying to store them on the network, and I got a nice call saying, our network has no space left. Can you please remove all your scans? So now we use external hard drives to keep the backup data for now until we can find a more permanent space to store all of our laser scan data. But we've also found running scan data off the network tends to be a little bit slow and cumbersome as well. So for now, C drive or external storage devices where we store those. It only took, I registered these models myself. It really didn't take long. It was simple data. 12 scans doesn't really take a lot of time to register as compared to a floor that's like 40 or 50 scans. One of the biggest hurdles we probably had on this is once it was registered, trying to align it to the architect's model. Because the model wasn't built from scanned data, it was difficult to figure out how to align it properly. So we used the grid lines in the systems to align the model to the scan, and that's where we found that it was actually short on both sides when it was lined up. It allowed us to make those changes, however, before they became problems in the field and actually saved us on that. So doing something for us that wasn't originally thought, but added more value to the project. And then using Edgewise to extract the piping data to get those existing pipes in the model to start coordination around. So these are a couple of images. So the top one is a screen capture from Edgewise, the orange data being all the existing piping, and then bringing that in Revit to show where all that existing piping falls. So some of it being inside of walls, some of it being in the center of rooms. So those ones that were in the center of rooms, we needed to make sure that got rerouted into a chase or into a wall to make sure that they weren't showing up there after the fact. So something else that came up from the pre-board scans that I'll talk about, the cleanouts. So as they were building and drywalling, I got a call asking to locate some cleanouts and wasn't quite sure what they were looking for. Here the drywaller had closed up the walls and they were missing some cleanouts. Rather than ripping all the drywall out, we were able to take the pre-board scans, verify where those cleanouts were, and measure off of column lines so that they could poke the holes in the walls where they needed to be, especially since one of them was actually tiled over. So that saved them a lot of extra rework by identifying how those cleanouts were. Also, they had told me they needed 12 cleanouts, and when I looked in the scan data, there were actually 14. So we were able to identify where those were with the scans and figure out how quickly they could make the holes rather than having to redo all the drywall work and the tile work. So in here, we have the Navisworks model with the existing piping model that was created in Edgewise and brought into Revit. This allowed us to take a look at the collisions with the cyan color being all the existing piping, and then you can see where the green duct work and the other piping were. So we were able to coordinate with all of the existing systems so that we didn't have these issues in the field later. If we were going to do this the old way, hand measuring all the piping for existing locations, having them work around it in the field, having them reorder components, rework lines. Meg Gas is a big deal in healthcare. If you have to redo Meg Gas because it's not coordinated, it takes a lot of extra time because the lines are sanitized as they. So we were able to say about a total of 15 days, well, I'm sorry, 1 day per reorder, estimated total of 15-day delay, or 120 regular hours in the schedule and added cost for more parts. By doing this, by using Edgewise and scan data and modeling, it took 8 hours in the field, process was 8 hours, and about 4 hours to model the pipe. So by running some numbers and talking to some subcontractors, it's estimated that we saved about 83% using scan data and Edgewise on this project. which is a pretty impressive number. I didn't even get that until I started doing this presentation. So some of the specific challenges with this project, I've mentioned a few already, but one is coordinating and keeping up with the schedule. For this type of project, they want it done and they want it done now. There really isn't a whole lot of room for error. And being able to get out there, luckily this job site is literally 10 minutes from my office. So if they called me, I could be there in 10 minutes. So the ease of location was a big help for this, but a lot of the times you don't have that. So keeping the PM and the super involved with what you're doing and making sure that they're notifying you of when the schedule has time or when it's appropriate for you to come and scan was a big challenge in this one. And then delivering coordination drawings that worked with existing conditions, as there is little time for rework. So it's, again, working in the schedule restraints and making sure we could deliver what we needed to deliver in the amount of time. So the manager, project manager and superintendent, getting their support, getting their buy-in, getting their feedback, making sure they're involved, making sure scanning happens when ideally there's nobody else in there, but as few as people as possible to make sure you're getting the data that works for what you need it for. I don't know about anybody else, but I did not want to scan at 1 in the morning. So we tried to work around that as best possible, sometimes catching lunch breaks or afternoon breaks. Placing enough targets for the scan to easily register. So if you are doing target-based scan, I highly recommend every time you set the scanner, looking through the eye of the scanner, making sure that you have visual to at least 3 spheres. The reason I say looking through the eye is because I'm 5'3", so if we have the scanner up high, I might be able to see a target, but when you actually look through up there, you may not see around a column or you may not see around a wall or something like that. So I always say to look through the eye. There is new non-target-based registration. I don't have a lot of experience with that yet, but I intend to start trying that one out. And then making sure subcontractors understand the importance of following signed-off coordination drawings. While we've done as much as we could do with scanning, modeling, coordinating, if the subcontractor's foremen aren't following those coordination drawings, it doesn't mean anything. So staying on top of them, making sure they understand that, going out to the field while they're doing their installations, really helped them to start understanding what we were doing and how we were doing it. And with that, I'll turn it back to Kevin.
All right, fantastic, Melinda. That's a great project. Let me ask a couple of questions here if I can figure out my chat window here. All right, we've got a couple questions I want to ask right now. First one, does the scanning and modeling include both the structural components as well as mechanical and electrical equipment?
No, we only modeled the MEP system and just the MEP systems that we needed.
Okay.
For electrical equipment, I didn't get too involved with individual conduits. If there was a large rack of conduits, I would just model it as a rectangle to save on time.
Okay. Okay. And the next question, did you get any survey control or did you just use targets?
For this project, there was no survey control set up, so it was all just target-based. Some of our larger projects were definitely working with survey control to be able to better tie it into the model, but in this situation, because it was the 6th floor, there was no survey control set up.
Okay. Okay. Perfect. All right, well, let's move on to Alan's presentation. Thank you, Melinda. Alan, let me give you control here. It should be all yours. Go ahead and take it away.
Thanks, Kevin. So our project was created a BIM model of the underground piping systems at the Huntington Memorial Hospital. First, I'll introduce a little bit about the firm I work at, P2S Engineering. We're a consulting engineering firm. We also do commissioning, committed to innovative design, sustainable solutions, and high-quality services. We have a central office here in Long Beach, California, and another in San Diego. We're a full engineering firm, mechanical, electrical, plumbing, technology. We consider ourselves solution specialists, so we basically any job we can get our hands on, we usually can tackle it. And with things like that we've acquired, like the laser scanner, it helps us complete those projects on time and high quality. We work with central plants, industrial facilities, educational facilities, laboratories, healthcare, entertainment, transportation, basically the whole gamut. The project I'm presenting is the Huntington Memorial Hospital in Pasadena. It's quite a large campus. Just the two towers you see here, 625 beds. They had major expansions, a few years ago, but they're starting to get old again, and there's not much documentation. I think some of the supervisors and managers that work there have been there for a while, so they know what's going on in their head, but there's not much on paper, when they need to do renovations and things like that. So that was our first problem, our first thing that we had to get through. So as I mentioned, we need to create an as-built design because they're upgrading some of the buildings for code compliance and just adding service. We were given, there's hundreds of feet of these utility tunnels connecting the buildings across the entire campus, full of, as you can see, lots of different systems. Our final deliverable was a Revit model, and we're working on construction documents right now. So Melinda hit it pretty well on the unique challenges for hospital projects. Kevin, too, there's very critical systems for life safety. There's multiple disciplines in a very confined space, especially the utility tunnels that we were looking at particularly. This is just a shot of one of the intersections of the tunnels, and you can see there's clearly a lot going on. And even looking at a drawing, you couldn't see much, or you couldn't pull much from that. So that's where, the laser scanning technology is really advancing, designs and redesigns. As mentioned before, there were little record drawings, and if they were, it was kind of just things that you couldn't really work off of, and then they could be out of date as well. So here I'll touch on the fume collection workflow. We used the same scanner that Melinda did, the Faro 330, I believe, scanner. Pasadena is just a bit of a drive here from Long Beach, but the freeways, as you know, in LA are not always the best. So there was a big problem with setting schedules with the owners and the managers and the team members to get everybody there at the right time when they were expecting us, and not overstepping our boundaries really when it came to the building owners and their facility managers. Being a hospital, we had to check in every day. They didn't want to issue us a pass and have you come and go as you please. They wanted to make sure they knew when we were coming, which wasn't a problem for us. We just, make sure we check in, get our badges, and they walked us through the tunnels when we first got there and before we did all the scanning. But once we, did our first couple runs of the tunnels, once we checked in, they kind of let us go on our way. For this particular project, and it's still ongoing, we've taken 100 scans in different locations, whether that's the utility tunnels or the mechanical rooms to a lot of the buildings and all the connection points in between. For the registration, we used Seeing, and I think it's important to have, if you do have a background of the area that you're scanning, what we found out is to make it easier on the back end in the office when you do the registration is to really locate where you took each scan. It just makes the process a lot quicker on the back end. So you can see that the as-built and the laser scan is basically exactly the same as how the drawing turns out. And I thought that was pretty interesting, because I had never really thrown architectural backgrounds onto our scans, but it lined up exactly perfectly. And sometimes it doesn't, as Melinda was saying, their backgrounds were off, a foot or two. So that's something that you can come back to them and let them know, hey, you guys maybe need to update what you have. So we've been trying to train multiple people on using the scanners. The particular scanner we're using is pretty user-friendly. So it's quick for me to, here's how you scan it. You basically can just set it up and it kind of does its thing, but you have to have a keen idea of what the laser scanner is trying to do. It needs to have line of sight of, it's not going to be able to look around walls. So we usually try to take as many scans as possible, within the time limit, just so we make sure we cover all our bases and there's nothing that we missed. But luckily, if there are spots that you need to go back and do, which we have had to, you can basically just restitch and re-register the scans, on different dates, all into the same model. So that helped us out. So we would do one section of the tunnels, come back, model it. I realized we need more section of the tunnels, go out and get more, bring that in. So just with Edgewise, there were about 1 or 2 of us. We actually modeled all the piping and conduit, as well as the structural, which was a fun challenge. Then we had 3 to 4 designers working once it was in Revit. So as Melinda said again, the scans are pretty high data, and you need somewhere that all the team members can access the scans. We're still in the process of figuring out what's the best solution for that. But there's the Scene Web Share application. It allows you to basically do a virtual walkthrough of your scans. So you can jump from scan to scan, look around, and you'll see in the next slide, it was helpful for us. We didn't have to make that trip back out to the tunnels. We were able to basically, excuse me, we were able to basically be there without having to waste a day or half a day driving out and figuring out, oh yeah, okay, that's what that was. Because a lot of times, even when you're trying to do as-built and you just have a regular photo, you're wishing, oh, I wish I would have taken that photo, 2 inches to the left or 2 feet to the left. With the laser scanner, you're allowed to get a full 360 view of what's going on around you. As mentioned before, our final deliverable was a Revit model. Here we created a filter that basically we went and tried to identify all the systems that are in the tunnels. So whether that's cold water, conduit, oxygen, natural gas, chilled and water supply and return steam. It really helped us visualize what's going on. Again, with older documentation or none, it's kind of difficult to really comprehend what's going on, which you need to know when you're doing your design and redesign, in the next step. As mentioned before, areas that need additional scanning, you can just go ahead and add to your model. And I was actually pretty impressed. We hadn't modeled, I guess, to this degree of detail before with our laser scanner. We've used it on, we haven't even actually modeled every single time that we've used the laser scanner. I think Melinda touched on that too. It doesn't always have to turn into, laser scanner to model to construction documents. We'll even use it, we'll go and scan a facility just so that we don't have to waste the day or time going back to that location. We have it all in-house, and you can see as-built real conditions rather than looking at drawings. With Edgewise, it was a significant time saving. I'm not even sure if we would have been able to do something like this. Well, I guess I'm not as experienced on how they used to do it back in the day, but it seems like a significant savings. I couldn't imagine having to, trace out the pipes or draw them in a sketch and then try to bring it back to the office and figure out what actually was there and then just have regular photos. So it was a significant time savings. So we spent a few days out in the field collecting the scans, and Edgewise is pretty quick with the registration and the pipe modeling, and as well as the structural modeling in it, and it's very accurate. So just to touch on a few tips and tactics when working with hospital or medical center projects. Melinda had a good amount of them, but it's good to get organized early. This was the first BIM project that this hospital had been involved with. They were kind of iffy about it. The owners, they've been doing it the same way so long, but I think our firm and I think the industry in general is really trying to move to that next step. And we have the technology now to do these type of things, and they are significant savings, and they're going to be more accurate. You won't have to be reordering things or basically have a contractor figure it out. It's good to develop a BIM execution plan for the project, which is guidelines and a layout of all the parties involved, stating here's what's going to happen in the project, here's what the deliverables are going to be, just so that everybody's on the same page. And it's good to get that early before you actually start doing the modeling, just so there's no conflict there. And also plan for the unexpected. So we tried to set up a meeting, every Tuesday if we needed to go out and scan, but they weren't always available for that. For us, there was some traffic. You might get lost data if you have other people using your scanner and they'll overwrite your scans, things like that. So it's good to plan ahead, and we always take the approach of, more is better. Take as many scans as you can within the time if you have a good time frame. And I think that is it. And I'll turn it back over to Kevin.
All right. Well, thank you very much, Alan. That was fantastic. That was a great overview of the project. All right. So I'm going to. I know I have a couple of questions specifically for you, Alan, and let me see if I can open up my chat box here. And then I want to encourage the audience, any questions that you have for either of these two individuals, please go ahead and submit your questions, and we will try to get to as many as possible. All right. Alan, first question I got here is from another professional out there with a laser scanner. I have a tunnel of a similar layout. Did you use survey control for this tunnel? And if so, how far apart? Did you use spheres, paper targets, both, or neither?
That's a good question. I should have mentioned that. I'm not sure what that survey control is. I'm not familiar with that, but we actually we don't use the targets. We haven't really needed to. That's why I mentioned we try to take as many scans as possible. So we usually do how Scene says, the cloud-to-cloud registration. And as long as you get, more than 30–40% overlap between your scans, it usually stitches together just fine, within a few millimeters of accuracy. As for the distance down, we did maybe every 25 feet, every 30 feet. So we just wanted to make sure, because there was, a lot of times it was a single run like that down the hall, but especially at the intersections when it kind of turns and it goes up and down, you wanted to make sure you got those covered.
Okay. And so there was enough variety for the cloud-to-cloud registration to work down the length of that tunnel. That's pretty good. I know a lot of times if you have a fairly featureless tunnel, you're going to want to put out some targets and whatnot to keep the registration on track, but that's good. Um, let's see, how much additional field work was associated with determining all of the different system types?
In terms of field work, I know there's been multiple people working on the project. I think some of our senior people have gone out more often to the actual site and checked out the connection points and things like that. But as for identifying the systems throughout the tunnels, we relied on the scans and the virtual scan application for us to basically walk through, and there were labels on the pipes, and hopefully we would hope that there were, they put labels at least every 50 feet or something for us to identify. But that's basically the process that we went through. Is we just kind of went from scan to scan and followed the pipe all the way through to the end and made sure we crossed that over to the Revit model as well.
Okay, perfect. This question is for both of you guys. How do you decide when to use survey control and versus targets on a project?
I'll start with that one since Alan doesn't have as much experience. On a project like this where it's an interior renovation, survey controls are really difficult to try to set up in my opinion, especially since we're not on the first level. But we have a 1 million square foot manufacturing facility that we're doing right now, and I don't know what we would do without survey control on that project. So I think the scale of the project is one thing, and the other is if there is survey set up for the project. So on the 1 million square foot project we're working on, there is a surveyor out there who has control points set up, and he's worked with us. Either you can use prisms or you can have them shoot the spheres and take the coordinates while you're registering. There's different ways you can do it, but we've found a lot of use with shooting the spheres and making sure we're working with the surveyor so that that control point is set up.
Okay. And this question is again for both of you. And this is a question that gets asked on every single webinar, and it's kind of interesting to track people's responses to this. But there's a lot of interest in targetless registration. Can you both kind of give us your experience with that, with targetless registration?
I can touch on that first. I want to say most, if not all, of our projects have used targetless registration. It seems that the scene software is more than capable of enough of registering the scans without using the spheres, which were provided with the scanner. So I think when we first got the scanner, we tested it out on our office. At the spheres, it seemed like it was an extra step, at least for us. Maybe as we get into more complex, or particularly I think they're useful for outside when you don't have as much objects to overlap your scans between. Then that's, I think, when the spheres become really handy. But for us, it's just I think we take enough scans that it overlaps. And we've been able to do central plants and pretty large buildings where we haven't needed to use any of the targets, interestingly enough.
As far as it goes for us, I think that the target list, I think there's just been a little bit of that fear. Typically when we're doing a scan, it's in the middle of a timeline. So we have a window, and once we lose that window, then we've lost the ability to capture that information. So if it's a flatness, levelness, we have a window when that slab has nothing on it. If we miss that window and we have to go back and rescan, there's a chance that there's going to be 50 pallets of crap on it, and we're not going to be able to capture it. So the target list has been a little bit of a subject where we just need to get out there and try it on a project where if we do have to come back and rescan, it wouldn't be a huge deal. Also, one of the things that just attending Autodesk University last week, they do recommend as you're doing the target list scanning to go ahead and have a laptop there so you can begin registration. That way you can see if something's not lining up, you can go ahead and throw in another scan.
Yep.
So it's really just a new process for us to try to figure out what works best, because there are situations where targets are tough to use. I recently scanned something where there was not a single damn metal thing in there. So putting up spheres was pretty difficult, and trying to attach paper targets to a building that's 150 years old with dust all over it, they just kept falling down. So target lists would have been a great way to go had we felt comfortable enough to do it at the time. So it's something we'll be experimenting with in the future.
Okay, okay, fair enough. Another question, whoever wants this one, did you also scan the ducts? And the question asks, I thought Edgewise could not do square rectangular elements. Is that still correct?
I can touch on that one. We didn't model the ducts. I know Edgewise is fully capable of modeling the ducts, but for what our purposes, I think it was just easier to model the piping. And I think I saw even Melissa had, you could technically model the duct as a pipe in Edgewise, just sort of as a placeholder when you move it to your other modeling software in Revit or whatever. But I think there's extra steps that you have to take before you do the duct modeling. So I think if that's your main focus, then you can definitely, get the square. And well, I mean, we were able to do the structural pieces just fine, and those were rectangular, and those imported right into Revit too.
Okay, Melinda, did you use any of the duct modeling tools in Edgewise?
No, we just did piping.
Okay, okay, okay. Yeah, there are a bunch of, I know the answer to this one. There are a number of new tools for modeling square ducting inside of Edgewise, and so that it's definitely feasible to go through and do that. What are the biggest differences you guys have found between hospital as-built BIMs and regular as-built BIM projects? What makes hospital BIM stand out?
For us, I think it's the amount of equipment in a hospital, typically office space or residential buildings, things like that, residence halls. There's just not as much equipment above the ceiling, where in a hospital, especially a renovation project like we had, there's so much more equipment with the Meg Gas, with the different types of exhaust. If you have clean rooms, there's extra exhaust for those. These type of equipment can go up into the ceiling. So as far as coordination goes, it's not always just the MEPs, but you also need to know the equipment. So if you have, for example, a hood door that goes up into the ceiling, you have to make sure that you maintain clearances above that. I only know this because it's happened to us. So there's a lot of extra challenges in my experience because of all of the different types of equipment and systems in a hospital that make it more challenging.
Did you guys model any of the conduit in these projects?
I'll touch on that one. We did model the conduit. Edgewise recognizes basically the cylinders, and as from my other slide, we created a filter, and we basically just made sure we identified which pipes were actual, pipe systems. And I think, Revit, it's technically a different system if it's a piece of conduit, but we weren't doing any sort of analysis of the conduit or anything like that. So we were fine with just keeping it as a pipe, or like a dumb pipe, and just, let our designers recognize that it was conduit and not, steam or something like that.
Okay.
Yeah, for ours too, it was the same. We didn't convert it to conduit. We just kind of kept it as placeholders where we knew we had to coordinate around.
Okay. Okay. Yeah, makes sense. If you just need coordination models, it doesn't really matter much. But just FYI, you're certainly capable of exporting it as a fully functional Revit conduit family or system. Let's see. Did you guys, how much experience do you have with above ceiling scans, and do you guys have any tips and tricks there? Alan, I'll ask you first.
We have definitely looked into that and been interested in doing that, but we haven't, hit any jobs or opportunities to do that. But I know that that would be something, very useful, especially during like construction or right before construction. I was pretty impressed with Melinda's. They were able to, get all that above ceiling work, which I still haven't gotten a chance to. So maybe she can speak a little bit more on that.
Oh, let me clarify. We were not sticking our scanner up into a ceiling grid.
Yeah.
And so it's a different situation if somebody's asking you to do that. Obviously, there's a lot of challenges, and I don't know how much you would actually gain from trying to scan while the ceiling is still in place.
Right.
Honestly, you would have to do a whole bunch of different ways of trying to register that as well. So our suggestion, because we have been asked, hey, can you come out and scan? And our question is, well, is the ceiling down? If the ceiling isn't down, there's not a whole lot of value, just because of how much information you're limited to collecting, and then the lighting as well. So if you're above the ceiling, you'd have to figure out ways of lighting the space to get accurate and good scans. So in my opinion, if somebody wants you to scan, you need to wait till the ceiling is demoed and then capture everything. Or if they want you to scan, you would scan before the ceiling goes up in a pre-board situation to capture everything, which is what we did for this particular project as well. We scanned before the ceiling went up.
Ceiling's
I agree with that too.
ceiling's definitely getting in the way. Was there
Not
any...
X-ray vision yet.
Yep.
One thing
would be nice.
One note I did wanted to touch on, if I could, because sometimes you'll get an error that, as Melinda was saying, that if it's too dark or something in a location, your scan data may be corrupted or things like that. In my experience, I've noticed that that's just for the pictures. As for the actual scans and the point cloud that the scanner creates from that, darker location, it still has all of the points and all the modeling points that you need. You just maybe when you look at that scan through pictures as well, it'll show up dark. But if you're using it, as your model, I would think that you could just go in a completely dark room, and since it's infrared laser anyway, it can hit that object and bounce back without there needing to be light. But you obviously want to have the scans and see what you're looking at as well.
Right. It certainly adds a lot of value to have that color imagery.
Mm-hmm.
Was there any pushback from the owner-operators needing to pay extra costs for laser scanning up front with the promise of savings later? And if so, how'd you guys deal with that?
So some projects we build laser scanning into the budget when we're proposing for the project. So especially if it's a renovation project, we know we're going to scan. So we'll build in the hours for registration and scanning up front because that's just part of our proposal. There are projects where we had started them, there was no scanning budget, and we found it as a benefit. So we submitted how long it would take and submitted that budget to the owner for approval because of the cost savings that it would have. So we would present a case scenario of, okay, if we don't scan it, this is what we have to do. And if we do scan it, this is what we're going to save.
Mm-hmm. Same for us.
Okay. Yeah, it makes sense. This kind of touches back a little bit on what we were just talking about, but which do you guys find better for collecting data, black and white or color scans? Is it worth the extra time to collect the color information?
I would say that, again, that depends on what the end use is. So if the end use is you're doing a demo scan and you really just need to create a model from it and nobody's really going to see it, I would say black and white all day, just because it's a double. For a 2-minute black and white scan, it's a 4-minute color scan. So you're doubling the amount of time and effort on the project. If it's something that the client's going to see that might be a marketing piece for the client, I would suggest color.
Okay.
I support that too.
Okay. Here's a question on Edgewise. What part of the modeling job done by Edgewise, what part of it is done automatically, and what percentage is still remaining that the user has to manually create. What did you guys find on this?
When Edgewise does its first registration, it does take a little bit of time, but you can obviously do some other tasks during that. But it's able to, extract most of the pipes that you need, maybe not 100%, but you can obviously go through and connect which pieces you need to connect, or extract certain pipes that you need in your model, or even delete ones that you don't. So I think it kind of depends on the project. If it's a smaller space and you know specifically which pieces you need to model, it might be better to just get the entire scan and kind of model the piping manually yourself. Or in our case, there was lots of pipes and long runs. We let Edgewise go ahead and run its algorithm and find the pipes the best it could, and we just went in and cleaned up and connected in areas where there was a break in the scan or something like that.
Okay. How did you guys decide on and Melinda, I'll ask you, how did you decide on the correct scan resolution to use?
I actually have like a little cheat sheet somewhere on my desktop that there's a lot of them out there with recommended suggestions for interior versus exterior scans. So we kind of go by that as a basis. Whether we need distance or the amount of points, what's really important for that particular scan. Typically for black and white, we try to do it where it's around 2 to 3 minutes. For an interior space, 2 minutes seems to be really well. But when you start to move outside, you have to change the resolution. So it's really all about that nice Excel spreadsheet cheat sheet where we can input what we have, and it kind of gives us a guide for what to use.
And where did you get that cheat sheet?
Another professional in the industry sent it to me, and I believe it was sent out in one of your past webinars or demos.
Okay, perfect. We might get some people asking for that. One other question, have any attempts been made to also use data from handheld scanners for complicated, hard to reach areas? Have you guys messed around with that any?
Not me.
I know that I think there are those available. We haven't quite gotten to the point where we needed to use one, or we have, I think, actually needed to use one, but maybe it just wasn't feasible at the time for us to get one. But I know maybe for, as we mentioned before, like above ceiling applications and things like that. But I've spoken to some of the people with the laser scanner, and I'm not sure if they register the handheld scans the same as you would your regular scan, from what I understand, but I could be wrong.
Oh, you cut out on the last part, I'm sorry.
Just that I'm not sure if the registration would be, as good as, like, say, if you took a regular scan down on the floor and then you went above ceiling with the handheld, that would be, the ultimate in the wish list, that you could connect those two together. But we haven't tried that, or I think the one or two people I've spoken of, it's a different file type, so maybe it doesn't connect quite with your regular scan.
Okay, fair enough. Okay, well, we're up on 2 o'clock, so I want to thank both of you, Melinda and Alan, for the presentations and for sticking around to answer the questions. Thank everybody for attending this webinar, and we'll see you on the next Workflow 4.0 webinar. Thank you very much. Bye-bye.
Thanks.
Thanks.